First, I must say it's great being here. Introducing myself, I come from the R&D center of AT&T, which is located not far from here in Israel. And some exciting stuff that we are doing there. So I'm going to talk about something that for my management is a real headache, right? For us engineers, quantum computing, quantum communication, it's exciting, but when I talk to a manager and they're saying, oh, I need to touch all the end nodes, I need to touch thousands of applications going to PQC, I'm not sure they are very happy about that. So who is to blame on that? We could put the blame on the godfathers of the quantum mechanics, the quantum era, as we are getting into. Certainly on Richard Feynman, whom I'm quite fond of the Superposition Guy podcast from Yuval Boger, and you always have a question, who is your favorite dinner companion? I think 50% of the people, I guess many here in this conference also gave this answer, is Richard Feynman, right? But we in AT&T also have a share in the blame. Professor Peter Shor, the inventor of the Shor algorithm for factoring the prime factor of large integers, he's actually coming from Bell Labs, which was part of AT&T back then in the 90s from New Jersey, and also Professor Grover is also from Bell Labs, right? So we do have a legacy in this field. So AT&T, I guess I don't need to introduce you this company. It's one of the three largest telcos in the US, together with Verizon and T-Mobile. It was founded, actually we just celebrated last month, our 147th anniversary. It was founded actually by Alexander Graham Bell, exactly 147 years ago. We are now focusing, after we actually spun out our media business with DirecTV and with Warner Media, so we are now focusing mainly in communication with mobility. We are leaders in 5G, and we have approximately 100 million subscribers, mobile subscribers, and we have fiber, 24 million, and it's rising of high-speed fiber. Mainly from the Bell Labs days, a lot of innovation, 8 Nobel Prizes, 3 Turing Awards, more than 11,000 active patents. I'm not sure there are many companies that can be proud of such a legacy, and annual revenues, I guess for the business guys, that's the main important issue, $120 billion, 160,000 employees, and we are conveying over our network 600 petabytes per day. That's roughly equivalent to 10 million 4K videos, and it keeps rising. Being a US-centered company, we are highly focused on the directives of the US government, and it mostly starts in 2018 with the Congress passing the National Quantum Initiative Act, that you can see it here, and that is actually the first major public law which outlines what the agency needs to do to invest in quantum information system and to allocate funding for this. It's $1.2 billion for 5 years. About a little more than 3 years later, beginning of 2020, the NSM-8, which is actually a directive memorandum issued by President Biden, and then they assigned a national manager to be responsible and direct the NSS, the National Security System operations, to threat mitigation, and it requires them to start with NSS encryption modernization. Actually, the target is to start that in July this year, and each of the agencies in the United States need to come with a plan, I believe that by the end of the year, telling what's the exact plan, what's the budget that it needs to for that plan to implement that, and it looks to be quite serious. And just 2 months ago, the National Cyber Security Strategy also issued by the US government. And let me have some quotes from that. What they're saying here, some quotes: we must prioritize and accelerate investments in widespread replacement of hardware, software, and services that can be easily compromised by quantum computers so that information is protected against future attacks. Again, that's the directive for the US government, but AT&T, working closely with the government, is expected to follow. And part of what the US this directive is saying, it encourages the private sector to prepare for the post-quantum future. So it's still not mandatory, but I guess that will be the next step. So us as a telco, well, where do we believe that we should be focusing? So the first, obviously, is the quantum communication, being it QKD, but I can tell you that we have also looked and looking at some other alternatives to that, other options. Post-quantum cryptography, okay? That's the need to replace every endpoint that is using cryptography, right, to change to post-quantum cryptography. And again, these are algorithms that are being initiated by the NIST, and we expect in about 2 years to have some final decisions about these algorithms. Currently, the leading one is the Kyber. Quantum applications, this is a quantum communication track, and also because in the quantum applications or quantum computing, we've just started to do our initial work. Okay, I'm not going to elaborate on that, but I can tell you that although, certainly for me, quantum computing is very exciting, then probably what we as AT&T will do is focus on the applications. Many applications are of interest for companies such as AT&T, going from the bottom, which is the physical layer, doing FFT, optical layer processing, mobile layer processing, and all that, and going up to optimization of network problems, anomaly detection. I think tomorrow a session about VRP, the vehicle routing problem that we are going to have. It's also of interest to us, actually, of the Israeli R&D Center, as we are developing the tools for AT&T for technicians dispatch. So we're quite familiar with the challenges there. I can tell you for a company as AT&T, we have, I think, about 60,000 technicians working daily. The problem is kind of the very equivalent to traveling salesman problem is practical, is real for us. It's a real pain point. So this is another area that we are going to address. And a few more. Again, we are not aiming, we don't pretend to be experts at the physical or the layer below. Okay, and I would assume us, and I see here the classic guys, I would assume a company such as AT&T to work closely with companies such as Classic to develop the applications and to hide what's underneath. And of course, standardization efforts. Myself, in the long history, working in ITU, T1E1, and few more standardization activities, it can be a challenge to navigate, to follow, to influence all these. So, how are we going to achieve that? What are we going to do? So first, we need to create quantum awareness. People don't really understand the threat. All the people here are quite familiar with the quantum technologies, with whatever goes with the industry. This is not the case for a company such as AT&T with thousands of engineers, networking people. They don't really know, so we are putting a lot of effort of explaining to them what they need to prepare for. We need to create inventory. We have millions of endpoints. We have thousands of applications. What areas do we need to touch? Where do we need to take this RSA module and replace it with Kyber? I don't know yet when. Customers, of course, always, it's something that we desire to talk to customers to hear what they're looking for. Cultivating talent, both internally and externally. If you need to build a quantum application, it's quite different thinking from what a classical computer software engineers would do. And we are looking for partnerships. And actually, this is part of the reason I'm here, looking for people. For sure, we are not going to do it all. There's a lot of knowledge in the industry, and we are looking to explore that. So speaking of partnership, it is very encouraging to know that there is quite a lot of money that is flowing into quantum technologies. This is a report from last year, industry report. $15 billion right here from China, about half the investment, which is pretty impressive. But we do know that the West start to rise up. Just this morning, I think we heard about, I think it was 1.2 billion dollars of euro by the French government that is going to be spent, and I know the same for the US and for the United Kingdom, Germany, and a few more. By the way, being patriotic, coming from Israel, Israel is spending close to $400 million 2022 versus 1.2 of the US, so it's pretty impressive, certainly beyond its ratio, either GDP or population, whatever. And in Israel, there are quite many, I think about 30 startups, okay, which is very impressive for a $9 million nation, sorry, 9 million people nation, and quite a lot of activity from the defense industry, the academy, and more. I did come across, and I want to share with you, a report by Global Data that was questioning, are we going through or going to expect a quantum winter? Mainly due to the fact that many of the public companies are struggling in the last couple of months. And the answer to that, according to this report, is definitely no. Even I would quote here, they're looking for a rosy outlook for the quantum domain, mainly focusing on quantum computing, with the financing the race to have more qubits, lower error rate for the qubits, and quantum communication. These are the main factors. And the main reason for that, it's a long-term play. A lot of the funds is coming not by the government, by the defense sector. It's not being judged or decided based on short-term financial ROI. So it does look to be optimistic. I hope, at least for the coming days, to keep this level of optimism. So when should we act? This diagram shows the Moscow inequality. Michele Moscow, I think he's Canadian scientist in this field. A few years ago, he shows this basic diagram equation that tells when you need to worry. So we have X. X is the time the data will have value. Some data probably goes through the network, goes through the fiber. Okay, if you harvested that data and you cannot decrypt it, it has no value. But some data, think about medical records, think about financial data, certainly about security, national defense data. Even if you can decrypt it a few years later, that would still have value. Why? Over here is the time it will take to change the network to allow it to be secure, mainly regarding the PQC, post-quantum cryptography. I can tell you, our R&D center in Israel is highly involved, actually leading the transition of AT&T to a public cloud, from the local data center to public cloud. It's not related to this, but we do understand the immense amount of work, how hard it is to take thousands of applications that were developed across 30 years and move them from a data center to a cloud. Just finding all the source code, recompiling that, changing blocks of code, making sure it all works, it's an enormous task. It's cost, I think, thousands of engineers by both AT&T and some of its outsourcing vendors are doing that, and it costs hundreds, probably more, millions of dollars. When I'm telling my managers, just know that after we have just done all this work, moving to the cloud, yeah, but you need to retouch it and recompile it. And do all these changes, I can assure you I'm not the most popular guy in this area. And Z is the time until the cryptographic, meaning the quantum computers, will be able to solve, to hack, to crack the existing, such as RSA, others algorithms. The good question is, what is the size of Z? I've heard, actually, here in this conference, one guy told me he believes that's 2 years. That's the shortest time I've heard. I've heard it from, let's say, from 2 years up to 30 years. Actually, thinking about it, it's quite ironic that we sit here in this room trying to protect the network, or looking to protect the network against quantum computers, and the guys in the other room, the other track, are building the computers that we are fighting against, okay? So maybe we should have a truce and then solve a lot of these issues. So what would be a practical approach, at least for the short term, for a telco such as AT&T? So first we need to identify all the threats. Remember, tens of millions, probably more end nodes, thousands of applications. We need to create an inventory of all the assets. We need to estimate where is the risk. We need to secure, or at least define a plan how to secure these assets, and to build an organization roadmap. And an organization roadmap is not just an Excel or PowerPoint. It means that you need to allocate the people, you need to allocate the budget, you need to make sure that you are going to meet that, and it is a long-term plan and long-term commitment. Where are the telco's touch points for PQC? So it's quite complex in a telecom. We have both fiber and we have mobile wireline and wireless network. We have many devices. We have the SD-WAN services, for example, which connect over the internet businesses services. Here we are using IPsec, which is using RSA or Diffie-Hellman. Okay, this is an area that we should touch. The interface from the RAN to the core. Again, IPsec, RSA, another area we need to touch. All the connections to the IoT devices, the connections to the public cloud, the user devices, the administration of the network, a very popular hacking point that we need to touch. So you can understand the challenge here. When we start and we're looking at the challenge, we understand the PQC constantly emerge, and so do the methods to break them. It's not that we have now an algorithm that we can say, for example, Kyber, this is what is going to work. We need to test it, we need to understand what are the implications, and we need to expect more to emerge in the coming years. So we do need to get hands-on experience in running these algorithms and evaluate their impact on the performance, scale, and support. And so we need to get wet, and it's not in the right picture of getting wet, but put your hands into the code and make sure you know how to embed that into the system. So to do that, we've built a testing lab which measures the different endpoints and how they affect the network. I have a short video. Let's hope it will run. It is running. We define the algorithm type, the number of iterations, and concurrent connections, and we start running it. Okay, and you can see we start getting data, the session time, how long does it take, what is the throughput of this algorithm, what is the server memory, the server CPU, the same, and see it here below, for the client. Okay, we analyze all that, and we can easily repeat this test for different algorithms, different methods. You can see here we have chosen another algorithm type, the Frodo, and once again we are running it. Moving to quantum communication. So it started basically with mainly in the area of the government and defense, but it's now being extended to other use cases in the finance, cloud data centers, healthcare, critical infrastructures. One such use case that I want to share with you that we are looking at, and personally I feel more attached to it, is for the remote work. Post-COVID, many of the knowledge workers started working in a hybrid model, splitting their time between the office and home, mostly home. So when I was recruiting people for my team in the last couple of years, many software engineers, I started getting many CVs from people from the defense industry, from the government, from defense companies, from the army. And I was asking them, why do you want to leave? And what they are saying, look, I was studying in university computer science. All my friends that work for the high-tech industry, they can work from everywhere they want, but we are required to work just from the office. We cannot take a laptop out of the office. We need to commute daily to the office. We got tired of it. We want to be like the rest of the guys, like the rest of the friends. It's mainly for what generation are we now? Generation Z, right? Something like that. Mainly for them. And it's not just a slogan. People are the greatest asset of this organization, and they need to respond to that. Okay, enabling secure communication is certainly a large part of this response. By the way, in the US, government, the defense sector, which includes the government, companies such as Lockheed Martin, all those who are not allowed to work from home, that's about 3.2 million employees. I would estimate, but that's my rough guess, at least 30-40% is what we call knowledge workers. So it's applicable to quite a large population. And of course, other areas in critical infrastructure, right? You need to defend it. Healthcare, you need to secure the medical record that goes through it. Okay. So am I the cost and fun? Okay, so quickly running through it, sorry. Layered approach, right? This is what the networking guys like to work with. So we have the top layer with cryptographic applications, the middle layer with the QKD network controller and the QKD network manager, and the one below, and few technologies that need to support it that we started looking. I must say personally, SDN seems to be very interesting in that. An operator would need a practical solution. We're looking for coexistence with the existing current infrastructure. Cost, think about investing in the US. We wanted to have real life environment, space, power, temperature, NABs, FCAPs, the management, the security, all that is critical, and of course interoperability. By the way, just so after me, another Israeli startup, Quantelar, is here. I guess they will address many of these challenges, so I will skip that. Oh, and this last one, I think just to give you a rough idea, QKD is not the only option. Another Israeli startup that we're at least talking to called the CyberRidge, they are doing optical photonic encryption at the photonic level. They are actually encrypting at the photonic level the entire optical layer. And if you do not have the cryptographic keys, even if you record the traffic, and you have a quantum computer today, you can actually, at least according to what they're saying, but it does seem to be substantialized, you cannot decrypt that. If anyone's interested, I'll be happy to connect you to this startup. I think it's quite interesting. So this is the summary. I'll not repeat that, but I will just tell you. Can you run this quick video? Yeah, so after I just finished, I asked ChatGPT what should AT&T do to work in the quantum space. I must tell you, it did save me a strategic consultant. A 5 seconds work. I'll not repeat that, understand the potential. Actually, it was quite good in what it provided. And one last slide. I want my son to be a scientist. Say it no more. I certainly like to get my hands on this book. Thank you all.